Today I'll talk about clustering. That is very important concept in machine learning. Um, so we will start with clustering techniques. But the idea of clustering is like you can think that this is in the class of unsupervised learning. So. Uh, the idea of unsupervised learning is you can think that you have no clues about the class of the example. When you learn about the example, you have nothing about the class. So um, the idea is what you can do with these examples are you can measure the similarity between the examples. So, for example, you can think that if we're talking about the iris data, I hope that you can remember what is the iris data. We have the sepal width, sepal length, and petal length, petal width, and petal length. All of them are the attributes of an example. So when we talk about the the attributes of the example, you can think that if we plot it, just select just only two of them. For example, you use the petal length and petal width. So you can plot the data, right? You can plot the data. We have no clues, so we have no class. So your data maybe is look like this. So one thing that you can do with these examples is you have to measure which 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 data is close to which one. For example, you have to measure the distance these between these examples, and the clustering is the idea of after you know the distance between these examples, you can group them. You can group the example that is very close to each other in the same group and very far from the other groups. This is very important idea. Close to the same group, but very far from the other groups. Okay, so the idea is quite simple. We will use the measurement technique. That is, normally we use the Euclidean distance. The idea of Euclidean distance is, if you have two, I think you're familiar with this. If you have just only two dimensions, for example, this is x and this is y. If you want to measure the distance between these two examples, of course, you have x1, right? You have x2 here. You have y1, sorry. You have y1 here and you have y2, right? This is the coordinate, the location of each example. So the distance or the Euclidean distance is the square root of x1 minus x2 square plus y1 minus y2 square. So how about in other dimension or higher dimension? Then for example, in 3D or 4D or with a vector that has n dimension. What you have to do is you can use this. For example, if you use 3D, you may have v, right? Yes, but if you have n, if you have n dimension, so the distance you can think that it is a summation for all dimension. For all dimension, for example, if your dimension is I, you can use x I of the first example minus x in another dimension of of the same dimension of the other example square. That's all. But to make it simpler, to make it simpler, um, in many applications, we don't need to take the square root because we just compare it. Okay, we just compare it. Which one is the closest? That's all. So we don't need to use the square root. So guys, that's all. So if you have for example, if you have the iris data, if you have the iris data and you have 4 dimensions, you have petal length, you have petal width, you have sepal length, and you have sepal width for data. For example, example 1 and example 2, this is, for example, this 4.2, 4 and 5.6, and 5 and 3.2, and 3 and 1.8, for example. Okay, so the distance of E1 and E2 you can calculate using square root of 3 minus 4.2 square plus 4 minus 5.6 square plus 5 minus 3.2 square plus 3 minus 1.8 square. And if you want to compare it with other, so you don't need to use the square root. That's all to find the distance between 2 examples. I'll stop this clip here. You already know the main idea of what is the clustering and what is the measurement, the distance measurements between 2 examples.